Welcome to our tutorial on frequency distributions. In statistics, when we're dealing with large sets of data, it can be difficult to make sense of all those numbers. Let's look at an example. Suppose we have collected data on the daily commute times, in minutes, for 50 people in Los Angeles. Here's our raw data. Looking at this raw data doesn't tell us much at a glance. It's hard to see patterns or draw conclusions. This is where frequency distributions come in handy. A frequency distribution, also known as a frequency table, organizes data into categories or classes and shows how many data values fall into each class. It helps us understand the distribution of our data, which values are common, which are rare, and what the overall pattern looks like. Let's learn how to create a frequency distribution using our commute time data. There are 6 main steps to follow. Step 1. Select the number of classes. For our commute time data, let's use 7 classes. This is a good number, not too few to lose important details, and not too many to become overwhelming. Step 2. Calculate the class width. We do this using the formula. Class width equals maximum data value minus minimum data value, divided by the number of classes. For our data, the maximum is 90 and the minimum is 5. So the class width equals 90 minus 5 divided by 7, which gives us approximately 12.1. It's usually best to round this up to a convenient number. Let's round up to 15, which will make our classes easier to work with. Step 3. Choose the first lower class limit. We can use either the minimum value or a convenient value below the minimum. For our commute time data, the minimum value is 5 minutes. Let's use 0 as our first lower class limit, since it's a convenient starting point below our minimum value. Step 4. List all lower class limits. Starting with 0, we add the class width of 15 to get each subsequent lower class limit. So our lower class limits are 0, 15, 30, 45, 60, 75, and 90. Step 5. Determine the upper class limits. For each class, the upper limit is 1 less than the next lower limit. So our upper class limits are 14, 29, 44, 59, 74, 89, and 104. Step 6. Count the frequency for each class. We need to count how many data values fall into each class. After counting, we find that 6 people have commute times between 0 and 14 minutes, 18 people between 15 and 29 minutes, 14 people between 30 and 44 minutes, and so on. Now, we have our completed frequency distribution for the commute time data. Let's visualize our frequency distribution with a frequency histogram. The height of each bar represents the frequency or count of commute times in that class. We can see that most people have commute times between 15 and 44 minutes, with the highest frequency in the 15 to 29-minute range. Now, let's look at a relative frequency distribution. Instead of showing counts, it shows the percentage of data in each class. To calculate the relative frequency, we divide each class frequency by the total number of data values, and then multiply by 100%. For example, the relative frequency for the 0 to 14-minute class is 6 divided by 50, which equals 0.12 or 12%. Another useful variation is the cumulative frequency distribution. It shows how many data values fall below each upper class limit. For example, 6 people have commute times less than 15 minutes. 24 people have commute times less than 30 minutes, which is the sum of 6 and 18. And so on. This can be visualized with a graph called an ogive, which plots the cumulative frequencies. Now, let's discuss how to interpret frequency distributions. They can reveal important patterns in your data. A normal distribution, or bell curve, will have frequencies that start low, increase to a peak, and then decrease again. In our commute time data, we don't exactly have a normal distribution, but the pattern is somewhat similar. Gaps in a frequency distribution, where certain classes have 0 frequency, can indicate that the data comes from 2 or more different populations. Frequency distributions are especially useful for comparing different data sets. For example, comparing commute times in Los Angeles with those in a smaller city like Boise would reveal significant differences. To summarize, frequency distributions are powerful tools for organizing and summarizing data. They help us visualize patterns, identify outliers, and make comparisons between different data sets. Remember the key steps to create a frequency distribution. 1. Select the number of classes 2. Calculate the class width 3. Choose the first lower class limit 4. List all lower class limits 5. Determine the upper class limits 6. Count the frequency for each class and remember the useful variations. Relative frequency distributions show percentages. Cumulative frequency distributions show running totals. Ogives visualize cumulative frequencies. Thank you for watching this tutorial on frequency distributions.